generator setting. Bob.
Control voltage on.
2.5, program device on.
Gyros on.
Gyro
Gyro erection on.
Gyro erection.
Generator setting.
Detect and launch loading has been completed. Roger. Connect assembly to igniters. Okay, tie down the lead. Roger, and install your protective tabs. Okay? Weight reading after last scaffold is removed. AFMTC telemeter calibration tape on. Start vibration and RPM recorders. Check all operating lights and meters for proper operation. Power panel check.
Power panel okay?
Control panel check.
Control panel okay.
Roger. Measuring panel check.
Measuring panel okay.
Roger. Cluster control panel check.
Cluster control panel okay, Bob.
Roger. Gyro erection off.
Gyro erection off.
Rudder drive on.
Rudder drive on.
Power transfer test on. Observe and record all voltages.
Power transfer test on. Voltage okay.
Power transfer off.
Power transfer off.
Cluster clear for launch? Clear to launch. Bob? Yeah. 021, deflection of jet main number 2. We've either got a relay.
For those dialing in, push *1 keys on your phone to be placed into queue. To ask a question using Twitter, please use the hashtag #AskNASA. And with that, let's begin. Let's start with Jeff Faust from Space News.
To the moon, the water signal that you saw with Sophia, is there anything currently on the books that would help in that regard? Thanks.
This is Jake. I'm sorry, we missed the very beginning of your question. Could you maybe restate it, please?
Sure. Let me try and summarize. Are any of the upcoming missions, whether they are orbiters or landers, including payloads on CLIPS landers, useful in helping to better characterize the water signal you saw with Sophia? Thanks.
Yeah, I can give you a little background on some additional CLIPS capabilities that we're looking at. The CLIPS flights, or commercial lunar payload services, will leverage capabilities of industry partners to quickly deliver scientific instruments, technology demonstrations to the moon. As part of that, NASA will be sending dozens of science investigations and technology experiments to the surface that will help us find and potentially extract later resources on the moon. So just an example of some of these that we're looking at moving forward. One would be the mass spectrometer observing lunar operations, or MSOLO. MSOLO will identify low molecular weight volatiles. It can be installed to either measure the lunar exosphere or even things like spacecraft outgassing and contamination, because we also want to understand what our presence might be doing to the water and the precious volatiles there. So data gathered from MSOLO will help determine the composition and concentration of these potentially accessible resources. Another example would be a neutron spectrometer system, NSS. NSS will search for indications of water, ice near the lunar surface by measuring how much hydrogen-bearing materials are at a landing site, and help determine the overall bulk composition of the regolith around it. Another example would be the near-infrared volatile spectrometer, or NIRVIS. NIRVIS will measure surface and subsurface hydration, carbon dioxide, methane, all resources that could potentially be mined from the moon and used by our future explorers. They also help map surface temperature changes at the landing site. And we mentioned Viper earlier. We also have another activity that will be going ahead of Viper. NASA's awarded Eclipse provider Intuitive Machines a task order to fly the Polar Resources Ice Mining Experiment, or Prime-1. So Prime-1 is a drill combined with a mass spectrometer, and it'll be heading to the moon late 2022. So this is a precursor drill, and it will fly with Viper, which will fly. It is a precursor to the Trident drill that's going to fly with M-Solo on Viper. So this is going to give us an example of how exactly to use the more enabled Viper mission when we get it there. So we do have a series of activities and payloads that are already set up to help us start measuring this and understand more about the environment and the volatiles there.
Great, thank you. Next question is Marcia Dunn from AP. Oh, sorry. Yes, Marcia Dunn from AP.
Yes, hi. Can you hear me?
Yes.
Hello? Yes. Yes, this is for the lead author, Ms. Hannibal. Could you tell me, please, how much, over how much area of the moon did you detect these molecules, the water molecules? If you could give some sense of how vast an area, how small an area, and how many molecules are we actually talking about, in the thousands, millions? I'm just trying to get a handle on how big and how much. Thank you.
Yeah, so the Clavius crater is the largest crater observed from the Earth, but it's not that big. When we looked at the moon, our observations extended from about a 50-degree latitude down to about 75 degrees in latitude on the moon. So we only covered a few degrees on the moon. What also, the abundances that we measured are only 100 to 400 ppm of water, which is not a lot. Like I said, these water molecules are not interacting with each other. They are individual molecules incorporated into these glass beads, so they're not in a form of ice or liquid.
Thank you. Next question. We have David Curley from the Discovery Channel.
Thanks for taking the question. You kind of touched on it there. I mean, this is an amazing discovery, but how much is there? Will it matter? Will it provide for astronauts if we need to mine it? Thank you.
Casey, I think maybe you could reiterate the amount of water.
Yeah, so the amount of water is roughly equivalent to a 12-ounce bottle of water within a cubic meter of lunar soil. But this, instead of being at a volume, this is spread across the surface of the moon. Whether or not it's usable for mining, I will turn over to Jacob.
Yeah, thanks, Casey. And this is the core part to the question, right? And I think several of us hinted at this, is that we really need to understand more about the water that's present. So we need to understand what form it's in. We need to understand how much of it there is. And this complement of approaches, of measurements that we can make. Some of them look at just at the surface. Some can look deeper below the surface. Some see water in different forms than in other forms. We need to gain that broad picture of what the resource stock really is at the South Polar region. We also need to understand how we can not only approach it as a resource, but how we can also use it as a science resource, because that ice also carries with it much information about evolution of the solar system, evolution of the sun, evolution of the moon-Earth system. So, it's hard to answer the question straight up. Is this discovery going to provide us with enough water to do anything specific? It's part of a process in moving forward and understanding volatiles and volatile cycles on the moon. And this is an important discovery because now we know that that water does exist outside of some of these places in these dark craters that are really hard to get into and really hard to operate in. So this might be an avenue for us to get to water a little bit easier.
Thank you. Next, I believe we have Joey Roulette from Reuters.
Hey, question for Paul and Jacob, kind of similar to what was asked before, but what will it take to know whether the water molecules can be turned into usable resources to support the Artemis program, like drinkable water, ingredients for rocket fuel, etc.? Do you think we'll know this from more remote observations, or will we have to rely on future robots or probes on the ground on the moon? Thanks.
I can give my first shot at answering that question. We already listed off a handful of additional payloads that are planned to go to the lunar surface. I think it's critical that we combine remote observation, which can give us the broad context. So, observations from Sophia, coupled with other observations that look more broadly at the moon, can tell us regionally where we see those signatures. But then we need to also get on the ground and sample. So we have, as I mentioned, the Viper mission is heading that way. And, I hope that you can see that this is kind of an iterative approach. So, for instance, we're sending the Prime 1 drill to help us understand better how to approach it when we get Viper there. That's a more capable vehicle. Answering the question exactly when we'll know is difficult. What I can say is that from a in situ resource utilization perspective, we have multiple approaches to extracting the water, multiple activities that are underway. And as we learn more, we'll know better which of those to develop further so that we can follow that approach. And it may be that there's multiple approaches because the water may be in different forms in different places. It may be more accessible. We also, again, have to learn just simply going up to the water, are we going to be disruptive to it to the point that we then can't use it? So, each one of these lessons helps us learn better how to query the lunar environment, the lunar surface on our next step moving forward.
Thank you. Next, we have Kenneth Chang from the New York Times. Kenneth? Hello, Kenneth. Are you on? Okay, before we go back to Kenneth, let's go ahead and take some Ask NASA questions. If you would like to ask a question using Twitter, please use the hashtag AskNASA. So we have a question from Liam Parker asking, what volume of water is found and does it suggest life may have been present on the moon previously? Sarah, can you talk about that?
Sure. So we covered a little bit about how much water is there. It's not a lot. And it's also water by itself is really not enough. There are other ingredients necessary for life. And the moon is, frankly, a really harsh place. The radiation environment, the lack of an atmosphere. There are lots of reasons we can talk about that where life is just not a thing that we think could have ever been possible.
Thank you. Let's try to jump back to the Q&A. Kenneth, are you available?
Yes, can you hear me now?
Yes.
Sorry about that. I just wanted to clarify a few things. In 2009, there was data from Chang about water in the sunlit areas. Is this a confirmation of that, confirming that it's water and not hydroxyl, but otherwise similar? And was there a confirmation of water in the deep craters from the L-Cross, or is there also that ambiguity between H2O and hydroxyl?
Hi, this is Casey. So I can take the first part of that. The observations from 2009 with M-Cube on the lunar surface were of the 3-micron band, which could not distinguish between hydroxyl and water molecules. What our detection today on the Sunlit moon is saying is that at least part of what MQ detected is in the form of molecular water. Maybe somebody else can take the L-cross part.
Sure. Let me jump in. L-cross did in fact find water, but that was of course looking in a permanently shadowed region. So the difference here is that we're now seeing it in sunlight as well.
Great, thank you. Next, we have Christopher Coquions from Sky News Canada.
Yes, can you hear me okay?
Yes.
Okay, and it's Coquino, so it's an odd name. No worries. First, congratulations to the team. And then a question about the map, the water map of Clavius. And did you see any evidence of movement of these molecules over time? In other words, these apparent glass beads that are containing these stray water molecules, are they breaking down? Are they moving at all due to solar wind or micrometeorite impacts? So was this, do you see a process? Is the map dynamic at all, or is that something to look for in future missions?
This is Casey. Yeah, that is definitely something that we are going to be looking for moving forward with continuing observations with SOFIA. With the current data, it's just a snapshot in time of one location at one time on the moon. So we need, in order to understand the mobility of water and if it's moving and how it's really stored, we need more observations of different lunar phases to really be able to get at that mobility problem of water.
Great, thank you. Next, we have Leo Enright from Irish TV.
Thanks very much. I'm wondering about the source of this water. You mentioned one possibility as glass beads on the surface being impacted by the solar wind. Now, I'm afraid I'm showing my age with this question, but I was actually in the science support room in the Mission Control Center during Apollo 17 when they were at Shorty Crater. And I will never forget the scenes in that room when they found orange soil, because everybody in the room believed that that meant water, and they were devastated, many of them, though they're scientists, when they discovered, well, maybe it wasn't. I'm wondering, could those be exactly the beads that you're talking about?
Hi, this is Casey. So those are actually different kinds of beads. Those are volcanic beads that were erupted during a volcanic process on the moon. The glass beads that we're talking about are little beads that form when a micrometeorite impacts the moon and melts part of the lunar surface. It melts it and could either deliver the water or form water from pre-existing hydroxyl, which then cools to form a little, what we are calling little glass beads. So they're the ones that they found on Apollo and the ones that we're talking about here are different beads. We do think that the Apollo glass beads like Apollo found may concentrate water, and hopefully we can do observations of the Apollo 17 site to possibly detect water at that location with SOFIA.
And if I may cheat and ask a follow-up, I'm particularly interested in the instrument that you were using. It's my understanding that it was designed and built by the Andor company in Belfast in Northern Ireland. Is that correct?
I'm going to pass this one on to Nassim.
Hi, are you talking about the instrument that made this discovery on SOFIA? No, that was made.
Yes, the CCD device. I understood it was built by Andor.
Well, I will have to get that specific information from the project, but the instrument itself was made in the U.S. by a U.S. institution. Yeah.
Okay.
Thank you. We will take another question from the phone lines and then go back to Ask NASA questions and then jump back to the phone lines. Let's start with Jim Siegel from NASA Tech. Jim, can you hear us? Okay, while we try to get through with Jim, let's go ahead and try to answer a question from Ask NASA. Based on the data for the near side of the moon, have we any assumptions for the far side? Could we find the same abundance and the same process? Casey can cover this question.
Yeah, so we believe that on the far side of the moon, the abundances are probably going to be very similar to what we see on the near side of the moon. We obviously would need more observations to really be able to tell if there's locations that may be different, though.
Great. And this one's for Paul Hertz. Will James Webb Space Telescope be useful for confirming and enhancing water detection on the moon?
Yeah, thanks, Felicia. Well, it is true that Webb has instruments which cover this 6-micron wavelength. However, Webb cannot look in the direction of the Earth, Moon, or Sun. Its tennis court-size sun shield blocks all light and heat from those directions, which is how Webb maintains its very, very cold telescope surface. So, no, it cannot look at the moon.
Okay, great. Here's a question for Sarah from Rev D. With finding water on the surface of the moon, do we expect to find more water at deeper depths of the moon?
So that's a great question, and one that we need more data on, right? So this instrument can only see the very top surface of the moon. But if we assume that these are in, these glass beads we've been talking about, right, they'll get mixed in deeper and deeper into the soil over time, right, as you get more impacts coming in and create new ones. So they'll get buried down to depths of feet, meters even. And we do expect to find that in various places on the moon. So one of the things we're looking at with the Viper rover, right, which is why it has a drill that reaches down a meter so that we can actually look at different layers as we go down and see where exactly that water is and how well it gets mixed into deeper layers.
Thank you. We're going to take one more Ask NASA question and then go back to the phone lines to see if Jim Siegel is available. Here's a question for Jacob. Are there going to be robots sent to mine the H2O and further explore the extent of the water quality?
Yeah, so that would be one potential option for how we might do this. Again, I'll go back to the point that we still have a lot to learn about how we can interact with these deposits on the surface, and in fact, which form we may go after. I think an interesting aspect to this result is Casey discussed two possible mechanisms for creating this signature, and it may potentially be a little bit of both. So at some point, we'll need to learn enough so we can start making decisions about, is it easier to invest in being able to survive the extremely cold environment and go into these shadowed regions, or will it be easier to access the type of water that Sophia is detecting right now? And that might require different amounts of energy or needing to be able to manipulate large amounts of regolith in order to extract that water. I can certainly envision ways that robots might be beneficial in all of those, but all of these are technology investments that we have to think about. And so this is a really good example of how this isn't only the Science Mission Directorate and our human exploration folks, but our Space Technology Mission Directorate as well. We all have to work together as we collect data from the science approaches to understand what technologies we need to develop, to getting our astronauts and robotically operated assets to the surface to get the job done.
Thanks, Jacob. Let's check in with Jim Siegel from NASA Tech. Jim, are you on? Okay, let's jump to Keith Cowing from NASA Watch.
Okay, I got your question for Jacob Bleacher, since you seem to be the most senior person who might know how decisions will be made here. Up until now, the Artemis program has put forth this sort of persistent mantra about focusing human landings at the lunar South Pole due to the potential water resources. And Jim Bridenstine has said, yeah, we're going to land there the first time. Now that it seems that water is a more ubiquitous, pervasive resource, one would think that this polar focus might pivot. I know you've had a couple of days at most to look at this. Are you now reconsidering landing sites as a result of this discovery? I know they've talked about global lunar access, but it really has been polar, polar, polar.
Yes, that's a good point that you bring up. I will note that in discussions we've had about Artemis and going to the South Polar region, right from the beginning of Vice President Pence saying that we're going to the South Pole, Water is one of the resources and rationales for going to this location. The other is that there are locations in the polar regions that have another resource, which is access to light for greater than 50% of the time. So just like here on Earth, locations on the moon will experience a daytime where they see the sunlight and a nighttime where they do not see the sunlight. And if you can take advantage of locations, for instance, at the South Pole, I mentioned that there are places where we see no sunlight in some of these deep craters. Conversely, there are locations on top of high ridges or mountainous peaks where we can see sunlight for more than half the amount of time. And that helps us to optimize our systems to take advantage of both the solar power as well as the temperature gradient there, or temperature inside the sunlight. So, water is one resource on the lunar surface, and we're certainly learning more about it and where it might be accessed. But it's not the only resource that we need that we will most likely use there. So right now, the discussions we have are still focused on the South Polar region.
There's actually an Ask NASA question that's very similar to this one. I'm going to give this to Sarah. This is from Van Applegate. Will this change plans for Viper landing areas?
Yeah, so not at all, right? So Viper is designed to look in permanently shadowed areas, but also to look in areas that are less shadowed, areas that get a little bit of sunlight where we think there might be water deeper, and also look in areas of full sunlight so that we can compare all of these different types of regions in the polar environment and really get at where the water is located. And so this is actually a perfect opportunity for Viper to follow up on these results and look at where the water is.
Great. Next we have Alexandra Witz from Nature magazine.
I'm going to just stay on the same theme. Are any of the upcoming rovers or Artemis missions planned to go specifically to or near Clavius?
Jay, I think that's you. Yep.
Yeah, I can speak for the Artemis missions themselves that involve astronauts. We don't have a final decision on the landing site yet. So we'll need to take all of this information into consideration. And in addition to access to volatiles, there are additional science objectives from the Science Mission Directorate that will be of interest to us. And so we need to find sites that balance that access to sunlight, the access to water, places that we can safely land to establish our foothold on the lunar surface. With all the other science and technology objectives. So the information we have here will certainly influence where we go and the decisions we make, but I can't say for certain that an Artemis mission would be going to that location specifically.
Thank you. Next, we have Kesha Rogers from the Executive Intelligence Review.
Yes, hello, thank you, and thank you for taking my question. Okay, so one of my questions was asked, so I'll just ask the question on what impact will projects and instruments such as the Intuitive Machines Lunar Ice Drill be for helping to extract the water that we found from the moon for use of the Artemis 3 or for crewed missions on the moon? So this is more about the extraction and use of the water ice, more so than the location of the water on the moon. Would this type of instrument help us to be able to extract the water from the moon? And that can be for Paula. Go ahead.
Well, this is Jake, and I'll go ahead and just jump in on this one. And if anyone else has anything to add, feel free. But absolutely, all the data that we collect every time we go to the moon becomes critical information for us to understand how we will conduct future operations. And that's what's so exciting about going to a place like the South Polar region where we have not been before, especially when you couple it with exciting observations from Sophia that we're talking about today. Everything new that we learn is valuable in how we develop those operations. And I've already mentioned the collaboration, the collaborative work between our mission directorates to collect the science information and data, develop the technology, and make choices about what pathways in the technology development to follow, enabling our astronauts to get to the surface and do the jobs we're asking them to do. So the drill data will absolutely be important to us in understanding, not only future missions, but we already talked about how it's of value to the next mission, Viper, that will follow up. So yes, the data from the prime drill will be critical for us moving forward, as will all of the payloads that are collecting data about the water environment and the surface environment.
Thank you. Next, we're going to take some Ask NASA questions. This is going to Casey. What was the original intention to observe Moon using SOFIA?
So, as a graduate student at the University of Hawaii, I began studying lunar hydration, looking at the 3-micron band that couldn't distinguish between hydroxyl and molecular water. And I was always questioning my advisor, Paul Lucy, why is this such a hard problem? Why can't we distinguish between the two? That led us down a rabbit hole to look for another way to look for water. And it turned out that 6 microns has a unique spectral fingerprint that is specifically for water. And so we went and started looking at instruments that could potentially make these kinds of observations. We found that no spacecraft currently or in the past had the ability to measure the Moon at 6 microns. And from the ground, the Earth's atmosphere does not transmit any signal. We thought about doing instruments on balloons, but the balloons took some time because we would have to build the instrument to look at the Moon in search for water. And then we figured out that SOFIA had an instrument that was capable of doing this, and so we ended up proposing, and we were awarded some director's discretionary time to test this observation, and it turns out to be pretty great.
Great, thank you. So this question should probably go to Casey, and maybe Sarah can follow up. This is from Dina. How can water exist on the Moon without an atmosphere to protect it?
That's a great question. So I mentioned briefly that we believe the water is being stored inside these micrometeorite impact glasses, and these would shelter the water from being lost to space or migrating to the lunar poles. And this would mean that without a lunar atmosphere, the water could stay on the surface of the Moon. Sarah, would you like to expand on that?
Yeah, that's basically the deal, right? Once you create these little glass beads in a very sort of hot, violent way, right, that melts the glass, and then the water gets trapped in there, and there's just no way to get it back out again. You can't. It's locked in, and so it is able to withstand the harsh conditions there at the Moon.
Thank you. This question is to Paul. How does the discovery of water on the sunlit surface of the Moon affect the focus of future NASA missions with respect to further probing the observation of more distant objects and planets, such as meteoroids and asteroids along with Mars?
Yeah, that's a great question, and I'm going to answer it by saying I don't think it's going to change it at all, because we've been focused on looking for water all over the solar system for quite a while. Our Mars strategy, how do we pick where our rovers and landers go on Mars, is driven a lot by where do we see evidence of past water on Mars. We want to go and look for how that water has affected Mars and whether there's any evidence of past life on Mars. That's exactly what the Perseverance rover will do on its way to Mars right now. We've also orbited the Ceres asteroid and looked for water on its surface. We're building a satellite called the Europa Clipper, which will be orbiting Jupiter and studying the moon Europa, which is known to have a subsurface ocean on Jupiter, which sometimes breaks through to the surface. So we'll be studying the surface as well as the interior of Europa. We're sending a quadricopter out to Saturn's moon Titan, which has a system, a hydrology system that's based on methane instead of water. And so looking for water all over the solar system is something we've been doing for quite a while, and we've learned that the moon fits right into that strategy.
Thank you. We're going to jump back to the phone lines. Let's talk to Chelsea Gould from space.com.
Hi, thank you so much for taking my question. This is Chelsea Goat of Space.com. I know we've covered this a little bit already, but I'm curious, what data do scientists still need, whether it's collected with SOFIA or other instruments, to give us a better idea of how we might collect and study water on the moon in person with rovers or crewed missions, and how difficult that collection might be, because it seems, at least at this point, that it's going to be fairly difficult.
So I think that we have gotten a lot of great data from various remote sensing techniques, but I think that the next steps to sort of really get at the big questions that we need answers to is to get down to the surface. With these CLIPS landers we've been talking about with Viper, and then of course with humans, that allows us to sort of see things at the centimeter and decimeter scale, where we can really get down and understand the distribution and location and the types of volatiles that we expect to be present there. And so I think that's sort of the next big evolution in our understanding of water. It's really going to require us to get down to the surface.
Great, thank you.
Yeah, and I can add to that real quick too, on top of what Sarah just said. You know, from an understanding how we access it, in addition to understanding the background of the water, the geochemistry of the water, we also need to understand whether or not it's affecting the geotechnical properties of the regolith it's mixed with. You know, is that surface harder? Is it more friable? And you know, how does that affect wheels, or how does it affect drills? So understanding physically what we're dealing with, that's going to be a critical piece of data. And just as Sarah said, you know, it really does require coupling these broad contextual observations from SOFIA, other orbital assets, with measurements right there on the surface. That will really help pull this together for us.
Great, thank you. Next, we have Ken Kramer from Space Up Close.
Hi, thank you for taking my question. For Casey, I'd like to know, can you talk a little bit more about, in detail, about your observations, follow-up observations of the moon, and when you will do them? Also like to know if this will be useful at other celestial bodies, like near-Earth asteroids, like Bennu. Would you be able to get any useful observations out of that? Thank you.
Yeah, so we have actually been granted 2 hours of observing time in the current observing cycle for SOFIA. We expect to be doing observing in the spring of 2021, but those have yet to be scheduled. We have also proposed to SOFIA for an additional 72 hours to observe the moon. We would like to map the entire near side and also look at these volcanic features and central peaks that we think might be concentrating water. We have yet to hear back on if we have been granted that time, but we are crossing our fingers. We have also proposed to look at asteroids to look for the 6-micron water feature. We've requested over 6 hours to do that as well. So this SOFIA can definitely be used to look for water on other airless bodies.
Great, thank you. I hope you get the time.
Thank you.
Thank you. Next, we have Christopher from Sky News Canada again. Chris?
Yes, thank you. Can you hear me okay?
Yes.
Okay, always want to check. The previous question actually anticipates, in your answer, Casey, anticipates my question, which is, I'm fascinated that you said you wanted to map the entire near side and look at volcanic features and central peaks that might be concentrating water. So is there a suggestion in that statement that another mechanism for this water to be present at sunlit surfaces could be tectonic activity that's leading to outgassing?
It's likely not tectonic, but extinct volcanism that happened billions and millions of years ago. So what we think might have happened is, if the moon had water prior while it was forming, or it had been delivered early on in the history of the moon, then it could have erupted the internal water onto the surface. And so we want to kind of see, by looking at these volcanic features, if that's true.
Okay, so you're looking at sort of primordial volcanism, not necessarily contemporary or relatively recent outgassing.
Yeah, that's correct.
Okay, great. Thank you so much.
Thank you. Next, we have Jim Siegel from NASA Tech.
Oh, thanks for taking my call. I'd like to hop on the back of Ken Kramer's question. It sounded to me as though, even though you have other ways of examining and evaluating how much water is on the moon and where it is and so on with Sophia and with the moon rover and so on, it sounded to me like there aren't any lakes or puddles of water. So I suspect that the initial Artemis flights are going to have to take their own water. And so that begs the question, well, if and when they do figure out how to mine the water from the moon's surface, would you estimate roughly how long it might take to really get that underway so that the astronauts don't have to bring their own water? For example, it's going to be 2026 or 2028, or would you hazard a guess about that? Thank you.
Yeah, I'll take that one. Again, it's hard to say a timeline for that because right at the moment, we don't actually know which type of water we're going after, what the source of that water might be. We have to figure out if we're going to have a technology that's going into some of these cold places, or are we going to be developing the technology maybe that can extract the type of water that Sophia is observing. Again, we have a cadence of payloads and missions coming up, especially working with the Science Mission Directorate and CLIPS to collect a lot of that information that will really help us narrow down what choices and pathways we need to take. You're absolutely correct. Artemis crewed missions will begin by bringing the water that they need, and we'll use that water. But one of the goals will be to continue to collect data that helps us understand what technology lines we need to follow to maybe one day be able to use the water that's there. In addition to that, you can also think about technologies that focus on recycling the water that you do have on the lunar surface. So, there's a number of ways for us to think about how to use the resources at the moon, take advantage of the resources we've already brought to the surface of the moon. I can't stress enough that we're really in the data collection phase right now to make informed decisions about the pathways that we want to follow for that.
Okay, thank you.
And that's all the time we have for today's Media Telecon. I'd like to thank the panelists and our operator for their time today. I'd like to ask panelists to stay on the line for a few minutes for post follow-up. If you joined this telecon late, you can listen to the recording again by dialing 203-369-3652. That number is 203-369-3652. Please join us for a Reddit Ask Me Anything tomorrow at 1 p.m. Eastern Time on the subreddit Space. Continue the conversation and keep the questions coming at Ask NASA. Thanks, and have a great day.
This does conclude today's conference. You may disconnect at this time. Speakers, please stand by.